Good morning, Professor. I'm Zhi Yang, and today I'll be presenting on security implications of wireless technologies in IoT application for my term paper presentation. So for table content, first we have introduction, followed by scope, followed by IoT application in smart building, followed by analysis of first source, analysis of second source, analysis of third source, and lastly, conclusions. So for first introduction, we'll be talking about motivation behind the research topic. So Internet of Things, IoT in short, is the future of technology and is already reshaping various industries such as agriculture, supply chain, and sustainability. It enables data collection for analysis using artificial intelligence and machine learning to make informed decisions making. For second on scope, we're setting up the research boundaries. The main focus of the paper will be talking about security vulnerabilities of wireless technology used in IoT and proposing solutions to mitigate repercussion. And third, IoT application in smart building. So smart buildings are able to adapt occupants' need with the help of IoT, such as adjusting temperature and humidity to increase the comfort level of occupants. And data is collected from devices and sensors placed around the buildings, and this data is being sent to artificial intelligence and machine learning to analyze them and generate useful insights, which will then be sent to actuators to take the respective actions to tweak the temperature or humidity to the comfort level of the occupants itself. And fourth, on analysis of first source, there are three main objectives. First, smart museum, which is building an indoor IoT architecture for museum visitor. Second, wearable device, which combined with image detection to provide users with artwork information. And lastly, Bluetooth low energy, BLE in short, to aid in transfer of localization information itself. So security vulnerabilities for BLE technology is that it's using AES-128, which is resistant to brute force, but prone and vulnerable to quantum computers itself. And the improvement will be using AES-256, which is resistant to both the brute force and quantum computers. And next, in this current situation, BLE technology is being used to enhance visitor experience through localization techniques so that our information can be sent real time. Similarly, for smart buildings, this technology could be implemented in collecting localization information around the buildings itself. And next, for analysis of second source, they have two main objectives. First, IoT smart homes, where application of IoT technology is being used. And second, RFID technology to aid for transfer of localization data within indoor environments. So the security vulnerabilities of RFID is that first is being prone to man-in-the-middle attack because any compatible reader could read the RFID tag data, and an improvement will be using multi-factor authentication, access control lists, and secure message queuing telemetry transport (MQTT). And in the current situation, RFID technology is used to enhance homeowners' experience through localization techniques so that controls such as lighting, temperature could be adapted to suit their needs. And similarly for smart buildings itself, the communication range of RFID could be extended with the usage of active RFID tags, and hence it could be incorporated into smart buildings to enable real-time monitoring, for instance, monitoring the congestion level and adjusting it during peak level itself. And for analysis of third source, so we have three main objectives. IoT architecture and standards should always be upheld for cost effectiveness and interoperability, and IoT set capabilities should be implemented system-wide. And lastly, core networks should incorporate cloud in the development of analytics for better fine-tuning, inference, and prediction. And in the current situation, we see that the problems arising for two sources. For source one, AES-128 is a weaker algorithm because it's being vulnerable and prone to quantum computing attacks. And for source two, the RFID tag data is prone to man-in-the-middle attack, and therefore the solution will be able to surface in source three, where the security vulnerabilities that is surfaced in source one and source two will be addressed by using the IoT model called the Open System IoT Reference Model, OSIRM. So for the conclusion itself, we have three main points. The security of IoT architecture should be the overarching focus, rather than the security of wireless technologies using IoT networking. And with a modern IoT architecture, IoT sec should always be established and incorporated in every means possible. And lastly, security mechanisms implemented in the OSIRM should never be exhaustive, especially with evolving cyber threats. And lastly, we have three main possible research directions. So first, how can we adapt the OSIRM for the IoT architecture implemented in smart buildings? And second, how can we constantly bolster our cyber defense through IoT-sec so that smart buildings will be less prone to cyber attacks? And lastly, is it possible to adapt the OSIRM into a plug-and-play concept where buildings will be able to implement it without much hindrance? And this is a reference page. And with that, I thank you for your time for listening to this presentation.